So today we're going to be talking about solving linear systems using inverses. We'll tackle Cramer's rule another day, but the first thing you're going to notice up here on the board is it says to solve the matrix equation for x. And so in looking at this, what I'm going to go ahead and do is I'm going to go ahead and solve this by using matrices. And so normally if you would solve that, you would sit there and say, well, I'm going to divide by A. Unfortunately, we can't divide matrices. So what we can do is we can multiply by something known as the inverse. And so what I'm going to do is multiply by A inverse. Now, one of the things to keep in mind when I multiply by A inverse is that I need to make sure that I multiply on the same side of A so that the A and the A inverse are paired up. So I'm going to multiply the A inverse here on the left side because remember what I just said. The A inverse and the A need to be right next to each other. Now since I multiplied it on the left side here, I've got to multiply it on the left side here. So I'm going to go ahead and squeeze in an A inverse. And so what ends up happening is on the left side, these cancel and I'm left with X. On the right side, I'm going to be left with A inverse times B. Okay, let's look at the second one. On the second one, I've got XA equals B. So in order to cancel out the A, I'm going to have to multiply by A inverse. But what I'm going to have to do is multiply by the A inverse on the right side because remember, they need to be paired up. So if I multiply on the right side of the equation, I've got to multiply on the right side of the equation. So what ends up happening here is the A and the A inverse cancel, and I'm left with X equals B times A inverse. Okay, the very last one, if you look at the very last one, we've got a step we need to do before we can even multiply the inverse, and that's we need to subtract by C. So what's going to end up happening is when you subtract by C, I'm going to be left with AX equals B minus C. Now in order to solve that, we're going to have to multiply by A inverse again. The key here is that we're going to have to multiply by A inverse on the left side here. And then over here, what I'm going to need to do is I'm going to need to put some parentheses in. So I'm going to go ahead and put parentheses around the B minus C. So what I end up getting is, after the A's cancel, X equals, and then on the right side I have A inverse times the quantity B minus C. So now what we're going to do is we're actually going to put some matrices in place of A and B and C. And so that's going to lead us to our first example. Our first example says to use an inverse matrix to solve the system of equations. Now I know you can solve this using elimination substitution, okay, but we're going to use an inverse matrix here, and that's what I'm going to want you to do. So come test time, no, you can't use elimination, and no, you can't use substitution. You're going to have to use an inverse matrix, and I'm going to check that. So if you notice here, I have 3x plus 4y equals 2, and x minus 2y equals 4. So now what I'm going to do is write an inverse matrix. Now how we do that is whatever is on the left side of the equation, the coefficients, that will be a matrix. So here, if you notice, what I'm going to have is I'm going to have the number 3. I'm going to have the number 4. I'm going to have the number 1. I'm going to have the number -2. That'll be on the left side. On the right side, I'm going to have the numbers 2 and 4. So what I'm left with is I'm left with the following. Now you're probably wondering, why is the x and the y like that? We have to write it that way so that when I multiply them, I end up getting the correct system of equations. So let's think about that. If I take row 1 times column 1, because that's how I would multiply matrices, I'm going to take 3 times x, and then what I'm going to do is add 4 times y, which is exactly what the first part of the equation is. And so that's why we do it that way. And so anyway, good rule of thumb, just memorize, you're going to take it times xy. Now what ends up happening is this resembles one of the equations that we looked at on the previous page. It resembles the equation ax, there we go, equals b. And so what I need to do is think back to how I solved ax equals b. And if you remember how we solved that is we multiplied that by A inverse. Key component here is that you multiply it on the left side. So when I do that, what ends up happening is the A and the A inverse cancel, and I'm left with x, and that will equal A inverse times b. So what I need to do over here is I need to find the inverse of A, and then take that result times b. So the very first place I'm going to start, find the inverse of A. So to find the inverse of A, we learned actually 2 days ago, 1 over A times D, which is 3 times negative 2, minus B times C, which is 4 times 1. And then I'm going to take that times, and remember our 2 little steps, switch spots, switch signs. So remember on the first diagonal here I switch spots. On the next diagonal I switch signs. So now what I need to do is simplify. So in order to simplify, what I'm going to go ahead and do is take 3 times negative 2, which is negative 6, minus 4. When I take negative 6 minus 4, I get negative 10. So what ends up happening is I end up having negative 1/10 on the outside, and my matrix on the inside will be negative 2, negative 4, negative 1, 3. My next step is going to be to go ahead and distribute that negative 1/10. I need to distribute that negative 1/10 to each of the 4 terms. And so I'm going to take negative 1/10 times negative 2, in which case I'm going to get 1/5. I'm going to take negative 1/10 times negative 4, which is 2/5. I'm going to take negative 1/10 times negative 1, which is 1/10. And then I'm going to take negative 1/10 times 3, which is negative 3/10. So that is the inverse of A. Now what I'm going to do is I'm going to come up here and I'm going to take that times B. So I've got 1/5, 2/5 times 1/10, negative 3/10. And I'm going to take that times matrix B, which is 2, 4. Now in order to do that, what you're going to do is you're going to use your matrix multiplication rules. Matrix multiplication is that you're going to take row 1 here times column 1 here. So when I do that, I end up getting 1/5 times 2 plus 2/5 times 4. From my second bunch, okay, my row 2, column 1, I'm going to get 1/10 times 2 plus negative 3/10 times 4. Last but not least, I need to go ahead and calculate those. So I'm going to end up here with 2/5. Here I'm going to end up with 8/5. 2/5 and 8/5 is 10/5, which is the number 2. On the bottom here I'm going to get 2/10, negative 12/10. So 2/10 and negative 12/10 is going to give me negative 10/10, which is negative 1. So my solution then, I need to write this as an ordered pair because that's how we write solutions to systems of equations, is going to be 2, negative 1. Okay, I'll give you a few seconds to finish writing that down, then we'll move on to the next example. Okay, the next example. We're going to once again look at another system of equations. Same exact type of problem. So I've got x minus 2y equals 5 times 2x minus 3y equals 10. What I need to do here now is write that as an inverse matrix. So remember, on the left side I'm going to have 1, negative 2, 2, negative 3. You're going to take that times the matrix xy, and that will equal 5, 10. So if you remember from the slide before, in order to solve this, I know that x is going to equal A inverse times B. So what I need to do here, oops, forgot the inverse sign there. What I need to do here is find A inverse. So I'm going to go ahead and take the inverse of this. So the inverse of that will be 1 over -3, because that's the first diagonal, A times D, minus this diagonal, which is -4. What I need to do on that first diagonal is switch spots, so the -3 and the 1 switch. And then on the next diagonal, I'm going to switch signs, so 2 and -2. So now in looking at that, you end up canceling that out. On the bottom, you're going to get 1. So really, it's 1 over 1. So here is my inverse. So now what I'm going to do is I'm going to take that inverse, -3, 2, -2, 1, and I'm going to take that times 5, 10. So once again, in order to do this, I'm going to take row 1 times column 1. So when I take row 1 times column 1, I'm going to take -3 times 5, okay, which is -15, and then 2 times 10, which is 20. For the next one, I'm going to take -2, 1 times 5, 10. So -2 times 5, which is -10, plus 1 times 10, which is +10. So in looking at that, you can see that the solution is going to be 5, 0. So my answer will be the ordered pair 5, 0. Okay, once again, I'll give you a few seconds to get everything written down, and then we'll move on to our next thing, which is the area of a triangle. Okay, what we're going to do now is we're going to look at how you can find the area of a triangle given 3 points. So what's going to happen is you're going to be given any 3 points on the coordinate plane, and based on that, you can find the area. So if you look here, I've got my first point, which is x1, y1. I've got my next point, which is x2, y2. And I've got my third point, which is x3, y3. Now how we're going to do that is we're going to write this using a 3 by 3 matrix, because that's what I can take the determinant of. And so notice, row 1 is going to deal with point 1. Since we need a 3 by 3, I'm going to just add the number 1 to the right. Row 2 will be point 2. Once again, you need to fill in, so you're going to add the number 1. And then row 3 is point 3. And then you're going to add the number 1. Now, for some of you that are probably wondering, what the heck is that, plus or minus? Okay, the plus or minus comes into the fact that area is always positive. So say, for example, you would get a negative value of your determinant. In order to get a positive answer, you would have to multiply by -1/2. Okay, so biggest thing what I want you to remember is I want you to remember that no matter what, your answer is always positive, because area can never, ever be negative. So now in this next example, what I need you to do is get out a sheet of scratch paper and make sure you write this matrix down, because I'm going to show you how to do this on the calculator. So it says find the area of the triangle passing through the points 1, 3, -2, -2. So as I said, you're going to want to jot this down, because otherwise you're not going to remember the points you need to enter in. So the area in this case will equal plus or minus 1/2. And so then now, what I need to do is here is put in point 1. Point 1 is 1, 3, 1. Now what I'm going to do is put in point 2. -2, -2, 1. And then I'm going to put in point 3. 3, -1, 1. So make sure you get that down. 1, 3, 1, -2, -2, 1. And 3, -1, 1. So now make sure you have your calculator handy. I need you to go ahead and enter that matrix that we just got written down as matrix A on your calculator. So remember, you go to Matrix, Edit, you're going to edit matrix A and make it a 3 by 3. So go ahead and enter that in. Okay, when you get done with that, what I need you to do is I need you to quit. So get out of there. Okay. Go to Matrix, Math, and you're going to notice that number 1 actually looks like, instead of being a capital D, it's going to look like this. It's going to look like lowercase d, e, t with the parentheses. Okay, so I need you to go ahead and hit enter. When you get done with that, your next step is to go to Matrix, Names, and A. What should end up happening is you should have something like this on your screen. Okay, you could put the right side of the parentheses, but you don't need to. What's going to happen is when you hit enter, you're going to get a value, and that value is actually 22. Now what I'm going to do is take that answer times 0.5. Now I'm going to use a positive 0.5 since the 22 was positive to start with. And when you take that times 0.5, or you could view it as 1/2, you're going to get your answer to be 11. So that means the area of that triangle is 11 square units. All right, so what you need to do is you have 2 parts to your assignment. Your first part of your assignment is on page 384. It's number 45 through 48. And then you have a second part to your assignment, which is page 392, 1 through 8. Both of those are due as one assignment tomorrow. So make sure you get those done. Page 384, 45 through 48, and page 392, 1 through 8.